My research is focused on the additive manufacturing technology, also known as the 3D printing process. Additive manufacturing is currently revolutionizing the manufacturing industry, with one of the most profound impacts seen in the aerospace industry. And this is because of the rapid prototyping capability that's afforded by this process and the flexibility in geometric design that's achievable by this technique. And that's giving rise to more complex turbine blade designs that are used in aircraft and propulsion generation engines. Now, the additive manufacturing process can be described as a layer-by-layer deposition and fusion process, in which the component that has to be developed is designed as a 3D computer-aided design model that's then split into 2D layers, and a focused laser beam is used to melt powder based upon the inputted geometry for each 2D layer. These 2D layers are then fused together to make your final component. There are currently numerous processing parameters that are used to develop your final prototype. As to name some of the few more common ones, these include things such as your laser power, your laser scanning speed, the powder layer thickness, and the build orientation. And optimization of these processing parameters are very important in order to ensure that you develop a component that's meeting your desired application requirements. Now, there's currently a number of challenges associated with the additive manufacturing process that needs to be addressed in order for it to replace conventional manufacturing standards. And my research is focused on addressing one of those challenges, and that is looking at the impact of build orientation on mechanical performance. These materials are actually unique in the sense that the way in which you manufacture a component with respect to the build direction or the z-axis, which is upward, will affect the mechanical performance of the material, and that's different from conventionally manufactured materials. So it's vital and necessary to look at this in order to understand whether manufacturing in a certain build orientation could potentially lead to early premature part failure, or could it potentially exceed the standards of conventionally made materials. And the overall goal is to develop